Now, I really didn't think it was possible to lose both shots of drilling this hole and then this hole here, but I think that just comes down to paying more attention to the drill press than the camera, which, all in all, is probably a good idea. But the lessons here are that drilling brass is hazardous. You have to be very careful. You have to make sure you've got everything clamped down in two directions so that it can't spin and it can't hop up, which it will want to do. And again, there's a limit to just how tight you can get a piece of metal like this. At some point, it's going to bend, and that's really, no good for anything. But this is the way it's done, and get it done as quickly as possible and, of course, as safely as possible. Welcome to the Secret Underground Laboratory Recovery and Salvage, where rude mechanicals do magic. Hello, I'm Bronze Age, Director of the Secret Underground Laboratory Recovery and Salvage. And today we're at the BF bench with a frou-frou lamp. Frou-frou is a term used in the antiques trade to describe little lamps like this with lots of stuff hanging off of them that pretty much useless as a source of light, but people like to put them on dressers and stuff like that, up on mantles, just to be pretty, and that's its only purpose. This one probably started out life as a candlestick. It's got two little candle cups here. Somewhere along the line, someone decided to turn it into a lamp. And I'm pretty sure that was in Europe because these little bitty holes are not big enough for American size wiring to go through. Over in Europe, they use 220-volt lighting systems. And America, we're still stuck with 110 for reasons that go way back to the early days of electric light bulbs. Now, what that means in practical terms is that with a higher voltage, you can get the same brightness of light with a lower amperage. And as a result, you can use smaller wires. So a lot of European lighting, when it gets to this country, especially antique European lighting, it has these little bitty tiny wires, and when they go to be rewired to North American standards, the holes are too small. And so this is not really a lighting or wiring video because somebody else is going to be doing that. This is a video about making these holes big enough for American size wires to go through them. Now, from the department of It's Always Something, this little cup has a plug screwed into it and no good way to get it out. Fortunately, I've seen this problem before, and I have a selection of metric bolts and nuts. Screw it down in there, tighten that one down, and then I can get a hold of it and it'll come right out. Drilling holes in the small parts is always a problem and a hazard because you've got to be able to hold this thing perfectly still while the drill bit goes into it. And drilling brass presents particular problems because instead of chipping up like steel does, brass is soft and the shavings will wrap around the drill bit and jam. It's possible to regrind the tip so that it cuts a little better in brass, but honestly, you're probably going to just ruin a drill bit. Now, the obvious solution to this problem is to make something that will hold the part so that neither you or the part gets damaged. Now, I'm going to start with the candle cup. It's got to be held in this position with the drill bit coming in like this. I'm starting off with a piece of scrap pine from a pallet. I've made sure that I've gotten all the nails and the screws out of it. And then I ran it through the planer so that I get crisp corners and some clean wood so that any pencil marks I need to make will show up. Then I take my candle cup and I measure this somewhere around 1 1/8. Hello, Rui Domo. I measure the bell here, and it's somewhere around 1 1/4. And the reason I'm picking those numbers is because that's the size of the Forstner bits I have. Since the candle cup's going to be held at this angle, I'm going to start off with 45 degrees. And I don't normally use a Sharpie for marking wood, but pencil marks just don't show up on camera. Now we're at the Packard Precision 12-speed drill press, where you'd think with 12 speeds there'd be one that was the right speed. Now speed's very important, especially on Forstner bits, because the bigger this bit gets, the farther this part is from the center, the faster it's moving as it goes across the wood. And at the speeds of like hand drills and stuff like that, which are usually somewhere between 1800, 2400 RPM, you can get enough heat from friction that these little small points will overheat, lose their temper, and you've ruined a bit. The solution to that is slow it down. And the larger it gets, the slower it's got to be. Bits this size need to be right around 1000 RPM when drilling in softwood. Now this is the most common kind of speed control on multi-speed drill presses. You've got 3 pulleys. Each pulley has 4 different size steps on it, which gives you 12 speeds. This little chart shows you how you can arrange the belts. They're usually meant to go straight from one pulley to the same level pulley on the other side. And I've got a choice of 730 RPM in one setup, 1500 RPM in the next setup, and I need 1000. So what I have done, instead of running the belt straight across, I got one belt that's going down to the pulley that's one step down. And that gives me right around 1000 RPM, which is ideal for the job I've got to do. Now this may shorten the belt life a little bit, but belts are cheaper than Forstner bits, and it gets the job done quickly and quite efficiently. I'm going to drill the larger diameter first. And the depth, I'm just going to eyeball it. Now this one will go through all the way to the bottom, and with a hole that deep, Forstner bits are real bad about getting clogged up. So I've got to raise it up and down. Might even have to turn off the machine and clear the chips, which doesn't make really good video. Alright, there we go. Now this is the type of jig I call a clamshell. The piece is going to go down in here, and of course clamshells have to open, so what I'm going to do is saw this down the middle. Now I can clamp this nice and tight with no damage to it, or to me, as I drill out that hole. We're back at the Packard with a 1/4 inch drill bit, drilling in brass, so I've got it set for 2400 RPM. That was nice and easy. This is the next piece. It's a little dish called a bobish. Its function is to sit underneath the candle and catch any candle wax that drips down. Although they certainly have no use in the modern era, they're still a decorative part of a lot of chandeliers and lamps. Now for this, I've got a 2 3/8 inch Forstner bit, and to accommodate the dish on the bottom of it, I've got a 1 5/8. And I've set the machine to 280 RPM. Now this is just a little bit looser than I like, and the bandsaw blade is not going to take out enough material to close this up tight. So it's going to get sliced on the table saw. And now we have the most complicated piece. This is the body of the lamp. The power cord comes up through the bottom into this space right here where the connection is made, and the wires for the lights come out through the sides through these two little holes. Now I'm going to have to drill a hole all the way through here to get it large enough for the cord, and then these holes have to be enlarged a little bit for the wires to come out. And most of the stress is going to be concentrated on where the arms are joined to the body. And this is just a solder joint, so it could break if I had enough leverage if the drill bit were to jam or catch. So what I've got to do is make a fixture that's going to hold this piece and clamp it as close to the arms as possible and eliminate the possibility of breaking them off. And what I want to do is drill down to about this depth and saw this whole board in half. When I clamp it together, it'll hold these arms nice and tight at these points, and that'll eliminate the possibility of it breaking loose if the drill bit jams. Now I set the drill press back to 1000 RPM for the 1 1/4 inch Forstner bit, and I've got the depth stop set so that I don't go too far down. Now all I need to do is drill a couple of small holes here in each piece so that the arms will sit down flat against the board, and we're ready to drill. Now for this setup, I'm not only concerned with keeping the piece from spinning, I'm also worried about it climbing up the drill bit, which is why I've got these extra clamps here holding this tight, hoping that this connection here will keep it from moving. All right, let's try that again. So close. Now I have to drill these two holes here, and the plan for that is to turn this piece around, which is going to require cutting relief for the bottom part here, and I'll be able to clamp it back together, which ends up looking like this. Now I really didn't think it was possible to lose both shots of drilling this hole and then this hole here, but I think that just comes down to paying more attention to the drill press than the camera, which all in all is probably a good idea. But the lessons here are that drilling brass is hazardous. You have to be very careful. You have to make sure you've got everything clamped down in 2 directions so that it can't spin and it can't hop up, which it will want to do. And again, there's a limit to just how tight you can get a piece of metal like this. At some point, it's going to bend, and that's really, no good for anything. But this is the way it's done, and get it done as quickly as possible and, of course, as safely as possible. This is Bronze Age for the Secret Underground Laboratory. I thank you for sitting through this combination of woodworking and light repair video. I would really appreciate it if you would give a thumbs up. Any questions or comments, I'm always happy to answer. I respond to all, and really not that big a deal because I don't get that many. So, until the next video, thank you for watching.